Hi, this is Janak Reddy Dubaka. NEET Physics quick revision, that is formula revision. This is part 2, motion in a plane. See here, this is projectile motion from the ground. Here the object is projected with velocity u, which makes an angle theta with the horizon. Here this velocity we can resolve into two components. One is ux, u cos theta, another one u sin theta. In horizontal direction, there is no acceleration. This u cos theta is constant throughout the motion. But there is an acceleration in downward direction. Therefore, vertical velocity changes. Therefore, from year to year, the vertical velocity decreases. Finally, it becomes zero at the highest point. Therefore, highest point having only one horizontal velocity, that is ux is equal to u cos theta. See, for this projectile motion, first after time t, in horizontal direction, final velocity Vx, it is always constant, that is equal to Ux. Therefore, U cos theta. And Vy is equal to Uy plus Ay into T. Uy means U sin theta minus Gt. Therefore, in horizontal direction, Vx and Vy. Therefore, V bar is equal to Vx hyphen velocity vector after t seconds, Vy j cap. Therefore, V bar is equal to U cos theta I cap plus U sin theta minus Gt j cap. This is a velocity vector after t seconds. This is, we can consider this as a final velocity vector. But whereas initial velocity vector U bar is equal to Ux I cap plus Uy j cap. Therefore, U bar is equal to U cos theta I cap plus U sin theta U bar is equal to U cos theta I cap plus U sin theta j cap. This is initial velocity vector. See here, in some questions may ask like this: at what time initial velocity vector and final velocity vectors are perpendicular? See, any two vectors are perpendicular, their dot product is 0. Therefore, U bar dot V bar is equal to 0. In dot product, here U cos theta, this is U cos theta, here is U cos theta. U cos theta into U cos theta, U square cos squared theta. U square cos squared theta plus here is U sin theta, this one is U sin theta minus Gt. Therefore, U square sin squared theta minus U sin theta into Gt. This becomes 0 is equal to, here U square common, cos square theta plus sin square theta is 1. Therefore, U square minus U sin theta into Gt. This becomes U sin theta into Gt is equal to U square. Therefore, here U square cancel. Therefore, T is equal to U by G sin theta. So, very important one. After this time, both initial velocity vector and final velocity vectors are equal. This is about velocity. Like that, after time t, what is the distance traveled in x direction? Therefore, in x direction, velocity is constant. Therefore, distance is equal to velocity into time. That is u cos theta into t. This is the distance traveled in x direction. But in y direction, there is an acceleration. Therefore, Sy is equal to uy into t plus 1 by 2 ay t square. Therefore, Sy I am taking y. U sin theta is nothing but u sin theta into t minus half gt square. This is the displacement in y direction. And this is the displacement in x direction. Like that. At any height h, here also at any height or any time, horizontal velocity always constant, that is Vx is equal to u cos theta. But whereas Vy, we have to write down Vy square minus Uy square is equal to 2Ay Sy. Therefore, Vy square is equal to Uy square plus 2Ay Sy. Therefore, Vy square is equal to Uy square means U square sine square theta minus 2Gy. This is Vy square. And this one is Vx. But velocity vector at a time h, that is V bar is equal to Vx I cap plus Vy j cap. Vx is equal to u cos theta I cap plus u square sine square theta minus 2Gy j cap. This is Vy, not Vy means square root. This becomes a square root. This is the velocity vector. See here, the magnitude of velocity vector we can write down Vx square plus V square is equal to Vx square plus Vy square. This becomes u square cos square theta. Vy square is u square sine square theta minus 2Gy. Therefore, V square is equal to, here u square common, cos square theta plus sine square theta 1. This becomes u square minus 2Gy. Therefore, V is equal to square root of u square minus 2Gy. This is velocity at any height. See, for example, here this is a point of projection, and this is a point where it lands on the horizontal surface. Therefore, for example, if you consider this is point O and this is point A, this is point B, or see, here is point A, this is point B. Therefore, in between point O and B, at the point O, here horizontal velocity u cos theta, vertical velocity u sin theta. Here also u cos theta, and this one is u sin theta. Therefore, from O to A or O to B, O to B, change in momentum delta P in x direction. Here also u cos theta, here also u cos theta. Change in momentum along x direction is 0. Along x direction 0. Along y direction dpy, final momentum minus initial momentum. Final momentum means mass into velocity. Finally, velocity is in this direction and initially upward direction. Therefore, this we can consider as a minus. Therefore, this becomes delta py is equal to minus mu sin theta minus initially minus mu sin theta. Therefore, dpy is equal to minus 2mu sin theta. Therefore, from O to A, change in momentum is equal to magnitude, it's a 2mu sin theta. 2mu sin theta. But from O to A, here also delta px is equal to 0. But delta py, p final minus p initial, final is equal to 0. Initial mu sin theta, mu sin theta. Therefore, delta p from point of projection to highest point, change in momentum is mu sin theta. Mu sin theta. Like that. From O to A or B, this is point B, landing point. O to B, average velocity V average is equal to, in horizontal direction u cos theta, vertical direction initially u sin theta, and finally u sin theta downwards, average velocity is 0. But whereas this average velocity only due to horizontal component, that is equal to u cos theta. This is the average velocity between point of projection to landing point. But from O to A means here point of projection to highest point, average velocity VAVG is equal to u by 2 into square root of 1 plus 3 cos square theta. This is also very important. Next one, here various parameters in projectile motion. First one is maximum height. H max is equal to u square sin square theta by 2g. This we can write down u sin theta means uy square by 2g. This is a maximum height. Next one, time of flight t is equal to 2u sin theta by g. This becomes 2uy by g. Another one, range. Range is equal to u square sin 2 theta by g. This becomes 2 into uy into ux by g. Therefore, this is a range. Here, range is maximum. R is maximum when theta is equal to 45 degrees. Therefore, formula for maximum range, R max is equal to u square by g. This is R maximum. And also, range is same. Range is same for two angles, theta and 90 minus theta. These two are complementary angles. These angles are called complementary angles. Another important thing, there is an important relation between maximum height and range. 4h is equal to r tan theta. Very important relation. And another relation, h is equal to gt square by 8. This is also another relation. Next one. Here, equation of trajectory. There are three equations of trajectories. First one, y is equal to tan theta x minus g by 2u square cos square theta into x square. This is one equation. And the second one, y is equal to ax minus bx square. This is also very important. Here, a is equal to tan theta and b is equal to g by 2u square cos square theta. And third one, this is very important. Y is equal to x tan theta. Y is equal to x tan theta into 1 minus x by r. These are the three equations of trajectory. So very important. In most of the problems, we can use these equations. See, for example, if any equation of trajectory given like this, y is equal to ax minus bx square. From that, we can directly find out a range. See here, range r is equal to a by b. Another one, h is equal to a square by 4b. Another one, time of flight t is equal to a into square root of 2 by bg. These are the three formulas, while the equation of trajectory is given in the form of y is equal to ax minus bx square. From that, we can find out a range, maximum height, and time of flight. See, for complementary angles, complementary angles, that is theta and 90 minus theta. Here two bodies are projected with an angle theta and 90 minus theta with same velocity. In that case, so very very important. Here the sum of their maximum height h1 plus h2 is equal to u square by 2g. That becomes r maximum by 2. See, many times directly asked on this formula. Another one, range is equal to 4 into square root of h1 h2. See, here range is same for both the bodies, and this is a relation between range is equal to 4 into square root of h1 h2, or r square is equal to 16 h1 h2. Another relation, time of flights t1 into t2 is equal to 2r by g. So many times it is asked when two bodies are projected with their complementary angles, then the product of their time periods is directly proportional to. Therefore, t1, t2 directly proportional to range. Next, another one. See, for example, this is x-axis, y-axis. If you projected a body with an angle theta, at the maximum height, its velocity is u cos theta. At the point of projection, kinetic energy is equal to half m u square. See, potential energy we are projecting from the surface of the earth, reference point taken as 0, therefore potential energy 0. Therefore, total energy is equal to kinetic energy plus potential energy. Therefore, this becomes half m u square. This is at point of projection. At highest point, kinetic energy is equal to half m into u square, means u square cos square theta, but this I am taking ke dash. For example, at the point of projection is kinetic energy ke, this becomes ke cos square theta, and potential energy is equal to total energy minus kinetic energy. Total energy constant. At the point of projection, total energy is equal to half mu square, and kinetic energy at the highest point half mu square into cos square theta. Therefore, potential energy is equal to half mu square common here. This becomes 1 minus cos square theta. Therefore, potential energy at the highest point half mu square into 1 minus cos square theta is sin square theta. Next one, very very important one. This is a projectile, and this one is the maximum height. See, from year to year, the time taken is t1, and from year to year, the time taken is t2. Here, these are the times at which their heights are same. Therefore, here is the height h, here is the height h. Like that, when t1, t2 are given, from this total time of flight, we can write down t1 plus t2. See here, from year to year, time taken t2. This is t1, therefore here also t1. Therefore, total time of flight t is equal to t1 plus t2, and height, this height h is equal to 1 by 2 into g into t1 t2. This is also very very important. Next one. This is about oblique projectile, means the body projected from the ground. Another one, horizontal projectile. Horizontal projectile. Here also, if a body is projected from certain height, this is the height h, we are projecting with velocity u, and this one also reaches the ground in a parabolic path. For example, after time t, its horizontal displacement is x, vertical displacement is y. Here, horizontal velocity vx, and this one is vy, and this is the net velocity v. Here I am taking alpha. Therefore, here also in horizontal direction there is no acceleration. Velocity does not changes. Vx is equal to u. But Vy is equal to Uy plus Ay into t. Therefore, initially it is projected in horizontal direction. Therefore, the velocity in vertical direction is 0 plus gt. Therefore, Vy is equal to z. Then velocity vector V bar is equal to Vx I cap plus Vy j cap. Therefore, V bar is equal to Ui cap plus gt j cap. This is the velocity. Then what is the angle made by the velocity vector with horizontal? That is tan alpha. Tan alpha is equal to Vy by Vx. That is equal to Vy means gt. Here is u. Therefore, alpha is equal to tan inverse gt by u. Next one. Displacement along x direction. That is x is equal to velocity u into t. But our y direction sy is equal to uy into t plus 1 by 2 ayt square. Ayt square. Sy I am taking h. Initial velocity 0 in vertical direction. This is half gt square. Therefore, h is equal to half gt square. From this, time taken from point of projection to reach the ground, that we can take as a time of flight. Therefore, t is equal to, here this becomes square root of 2h by g. This is a time of flight. See, this horizontal distance we consider as a range. Therefore, horizontal distance means horizontal displacement, horizontal velocity into time of flight. Horizontal velocity into time of flight, that is equal to u into square root of 2h by g. This is the formula for range. Next one. For example, this is a height h. If you projected with velocity u by making an angle theta with the vertical, therefore here this becomes u cos theta and this becomes u sin theta. Again, it is also reaches to ground in parabolic path. See, for example, what is the time taken to reach the ground? It is similar to a body projected from the tower with velocity u sin theta. Therefore, there h is equal to minus ut plus half gt square. Therefore, here h is equal to u means u sin theta minus u sin theta into t plus half gt square. Using this formula, we can find out the time taken to reach the ground. This is a horizontal projected. See, these are the important formulae from projectile motion. So very important. Every year in NEET exam, we can expect at least 1 or 2 from motion in a plane. The two, so most important, oblique projectile. Say that oblique projectiles, different parameters are there: maximum height, time of flight, equation of trajectory, like that. So this is a formula revision. So very important. One go through this video. So it is very useful. Thank you.